My name is Carlos Oliveira. My company is Shaping Cloud. We are based in Manchester, and we run the Manchester Windows Azure user group, as Richard has said. We've been going just over 2 years now, and as a kind of principle of the business and a starting point of the business, the concept was we are entirely cloud. We have no servers. Everything we do, we run on Azure. So all of our client projects that we deliver on Azure. Everything we do internally is Office 365, CRM Online. We're kind of the cloud fanboys of Microsoft, and we try and run our business fully cloud. And obviously that brings challenges, but it also means you get to do some cool stuff and you keep up to date. So anything that comes out of Microsoft in terms of cloud, we like to try and get involved with. I'm going to talk to you today about a project we did with Sheffield University. I mean, we put Sheffield University as they were the sort of primary drivers of the project. It was actually a collaboration, and I'll talk about some of the other partners involved, around environmental projects on Azure, and in this case, one particular environmental project. So the client, as I said, was sort of the University of Sheffield. They were the ones who approached us. They were the ones who worked with us. But it was a collaborative project between, there's a group called the North Yorkshire Universities, and 3 of those, Sheffield, Hull and York, had collaborated within their environmental teams on a piece of research, and had got funding from something called the Centre for Low Carbon Futures. So it's a government agency that's driven with reducing carbon emissions across sectors and across industries. And these guys in the teams and clever carbon people who are clever, and do clever stuff, had come up with a really nice bit of research and a way to calculate carbon emissions within the supply chains for companies. And they were looking for a way to reach out with that research and make it available and make it accessible for different businesses across different sectors. So the brief, transform this important piece of research and analysis into something that is commercially viable. So it was a funded project to begin with, and they had a certain amount of funding, but the aspect and that the focus was always that their funding will disappear. The government had just come in and announced that lots of funding was disappearing, and they needed something that would actually then be able to self-support itself. It means they can do more research, they can do more work in the field, and so it had to have a commercial aspect to it. It couldn't just be some fluffy, nice bit of university research that nothing ever happens with. So in terms of a way to deliver that, the web was obviously perfect. It's there, everyone can access it, it can go into companies, and you can go and demo it to companies. Nothing to install, it's simple. So a web platform was sort of the main brief. They wanted users to have the ability to map their supply chains quickly and accurately, without needing to know about the carbon methodologies behind it. So if you work in a company and you're in charge of your logistics and you're in charge of your supply chain, you have an excellent knowledge of your supply chain. You probably don't have a great knowledge of how carbon accounting works. So it needed to be intuitive and allow users to map out a supply chain that's in their heads in a language that they understood. So integrate into other industry standard databases. So there's one particular body called EcoInvent, which is like a industry or cross-industry standard database of, this is how you manufacture steel, this is one way to manufacture steel, this is the carbon footprint associated with that manufacture, here are all of the inputs to it, and it's broken down to 0.0 kilograms of quantities. So rather than recreate all of this information and put it into our system, we wanted to integrate and hook into what was already out there. The next bit is, okay, we've got the supply chain, we've got all of the details around it, we've got the weights and measurements and everything else. Now we need to run these carbon calculations. Now, running a carbon calculation on a very large supply chain is a big, intensive process. The initial research that they had done, they'd put together a Java-based application on one of their machines in the labs, and processing one of the bigger supply chains could take sort of 2.5 hours to get the final results, because there's lots of matrices going on, lots of calculations. So again, we needed something that was going to be quicker, that for an end user who's not sat there waiting for 2 hours. The second part of the research was they'd done analysis into how they could calculate the emissions, and they'd already done partnering with other companies, so local companies in the area, such as Sheffield Forge Masters. They'd gone in, worked with them, done their research, done their analysis of their supply chain, but then also built up a kind of a recommended way to reduce the carbon. So they'd done the research, they'd done the analysis, and they'd come up with a solution. And so the whole idea of the system was that you would go, you'd map your supply chain, you'd find out where your hotspots are, you know, what are the parts of your supply chain that are not carbon efficient, and it would try and plug into one of its existing examples as a way to suggest, well, maybe you could do this. Now, they call them interventions in the system. An intervention could be something as simple as putting a sticker on a machine saying, turn off after use. You know, they're split into various categories. Some are, you know, change all of your light bulbs to energy efficient ones. So it's not complex stuff, but obviously there's a complexity around how you map a result and a footprint and how the metadata works in order to say, here's a suggestion, have you tried this? And the idea was the tool would learn and evolve over time as more people used it. Well, I've just precursored myself. So the idea is that, you know, after you've done your mapping, you've done your supply chain, you've done your analysis, it wanted you to be able to then say, this is what we did, and here are the results we've had. And then other companies, the idea is that companies can work together rather than everyone just saying, well, this is my supply chain, I don't want to share that with anyone. The tool allows you to share your results and your data without necessarily, obviously, sharing confidential or information you wouldn't want available to the general public. So the architecture, you know, like I said, everything we do is on Azure. It won't surprise you. We're at an Azure conference. We built it on Azure. And the best way to think about Azure, and the way I think about Azure, is it's a bit like Lego. And you have just got all of these different building blocks within Azure that you can use in whatever combination you want to deliver the solution that you need. And you know, you can do all kinds of stuff with it. And the important thing is that because you can pick your blocks, you're always kind of right-sizing your application. You never end up with a load of stuff or a load of overhead or a load of processes that aren't actually necessary to your application. You can really tailor it to fit, and that's one of the nicest things about the platform is it's not just a cloud server that you can go and run things on. It's these little building blocks that you can connect together in different ways, and it's great for what we do. So the client layer was, you know, HTML5 and a browser-based application. HTML5, you know, it's getting there. We did have a conversation about Silverlight and the potential there, but we felt that with HTML5, as it evolves and it starts to do more of the things that we really want it to do, it's a very powerful platform, and it is the way it's going. I think even Microsoft themselves have acknowledged that with their new Azure portal. So one of the first building blocks is they've come to the site, they want to get into the site, we have identity, and you've got identity services and all kinds of different ways to hook in a nice, powerful and simple identity management system into your application. So first building block pretty much on everything we do is the identity layer. They get to a website. The website is your web role. So simple web role. You know, this is obviously a site that's not going to be huge usage. You're not going to have millions of people trying to run carbon calculations on it. It's just going to be a few users. So we don't need anything fancy. We don't need anything massive. A nice simple web role will do the job nicely. But it is a site that will be and is being used globally. And we want the site to be quick, and we want it to be responsive because it's a key part of what we're trying to deliver. You know, for it to be a commercial product, commercial people have, you know, limited time to do anything or look at anything. It needs to be fast and responsive. So we've got a CDN. It's simple. We plug it in, and we know that wherever you are in the world, you're going to get the content delivered to you as quickly as possible. We've already spoken a little about storage and how that's a great place to put images, things like that, fairly static content, non-relational data. So again, most of the things we will use storage, in this case blobs, to store all the data and the information. Again, database, SQL Azure, SQL for Windows Azure, whatever the terminology. I will end up calling it SQL Azure. I can't help it, sorry. It's just programmed into my brain. That's where we can store all the supply chain data. You know, supply chain is made up of processes and inputs at its base level. So you just got a load of processes, a load of inputs into those processes, each one with its own data. It just fits a SQL database perfectly in terms of what we'd want to do with it and how it needs to work. Then we get the sort of interesting bit. So we've now got a website up, we've got identity, they've logged on, they've got a nice site, they want to go into the system and they want to create a supply chain, they've done their supply chain, now they want to run a carbon calculation. Well, like I said before, the web role, we don't want anything massive. We're not going to have massive amounts of users using this website, so it just wouldn't make sense to build something into the web application. So instead, we want to message something, and we want to put a message out there saying, run a carbon calculation for us. We're not going to run it within our web role, and instead, we want to run it within our worker role. So having that split straight away just gives us a distributed architecture where we can scale up the amount of processing power that we've got in the carbon calculation part. You know, the heavy lifting of the system is all really happening there. And we can independently scale that to meet demand. So if we've got 1 or 2 users using the system running a carbon calculation, 1 worker role is perfectly adequate. If you start to get to 5 to 10 users all running carbon calculations, you know, in some of the workshops that Sheffield run, they'll maybe have 20 people in a room. They're talking them through as a sort of a bit like a dev camp, you know, build your supply chain, hit the button. If you've got 20, 25 of those things running at the same time, we want that to be able to scale up. We want that to be able to be as quick as possible for the users. So the Azure architecture just gives that to us in a really nice, straightforward manner. So I've said that we always use Azure, but there are justifications for it, and it's not a case of it's always just the right answer and we're always going to do Azure and that's it. We do justify it, and the reasons for Azure, certainly in this case, the main 5, we've got Damien speaking after me, I think after a break, about bootstrapping a startup on Azure. So, you know, we're going to deal with that a little bit more, but it is the perfect platform for a startup. You know, we mentioned previously how you can just get something up. You're not spending any money. You know, this is a university government-funded body. We're not talking massive amounts of money. They wanted something that they could get up without a large investment, and it is just perfect for that sort of purpose. Instant global reach for a global product. Like I said, you know, some of the biggest supply chain issues are in places like China, and they're actively pushing it into that market. One of the head people and head researchers is from China, and she is really trying to promote it there. So they needed something that was global and that would work everywhere. And again, Azure just gives you that up front. The distributed architecture is a perfect fit for this. We don't need an intense website that's servicing thousands of requests a minute, but we do need a very powerful back end that's going to be able to run these carbon calculations as and when they're needed. And using the application building blocks, we can do that, and we can configure things in different ways. And like I said, the architecture I've described could be reconfigured probably several different ways to achieve different things, how you need them to work. Automatically scaling. I mean, I've shown a picture of the Azure portal where I'm manually scaling, but that's just a visual thing. You know, there are now ways to use application scaling blocks where you can just scale up the worker role. So if it detects that it's getting a certain number of requests coming through, a certain number of carbon calculations are running, it can scale up another worker role. If another carbon calculation request comes through, it'll go to that worker role instead, and we can manage that process. It's got green credentials. You know, this is a carbon calculation thing. It's trying to save the planet, and you know, the fact that it's in the cloud, the fact that Microsoft does invest very heavily in its green technologies in terms of where the data centers are located, the way the data centers are set up, the efficiency and the general, you know, low carbon footprint of these data centers compared to certainly traditional data centers, on-premise hosting. You know, it's another tick in the box really in terms of as a solution for them. So the results, the tool was built and is live. It is the Supply Chain Environmental Analysis Tool, or SENAT, which is there, and it's up. I kind of wanted to just show you briefly the platform. I was having some technical issues, unfortunately, but you've got the web homepage there, and just to show you the sort of UI, I won't go into details on it, but this Firefox, there we go. This is kind of a supply chain, and it's a supply chain that's had the carbon calculation run. So it's HTML5, it's drag and droppable. The grey boxes are the processes, the coloured boxes are the inputs. So, for example, waste management has got several inputs into it. You run the calculation and it will just work out. So, for example, energy here, this is a Sheffield Forge Masters supply chain. The footprints, electricity. I think there's some test data up there that says boom. I don't think that is a genuine input, but it does all of this calculation for you on your supply chain. You've got things that are called upstream inputs here. This is, in terms of the traditional view of this, if you're a company, it's an Excel sheet with lots and lots of numbers in it. It's not presented in a way that you can call executive level, where someone would be able to look at it and say, what does this actually mean? And the whole point of the system was to try and make something that's visual. So you've run your calculation and you can see instantly, through color coding, through everything else, just where your carbon is coming from. Tools to export it and do all the other stuff. You still want the ability to Excel export, because the researchers do want to do some number crunching and things like that on it. But it just as a, when you're launching a commercial product, you have to take into account who are you selling it to. And if you're selling it to big organisations, you need something that's going to be really visual and something that they're going to like to use and work with. So the tool is live, and in terms of a client list, these are some of the companies who are using the tool. So something that had started up as an internal piece of research it could have ended up as an internal piece of research. They've been able to commercialise it, and not only been able to commercialise it, because if you're a university institution, it does open certain doors into certain companies, because a company assumes you're a university, you're not trying to sell us anything. Universities are changing, and universities need to fund themselves, and they do need to be commercial, and so more and more research teams are going to look into this now. We're Microsoft education partners, and we're working with various universities, and it's definitely a trend. Their funding's going away, it's harder to access, so they kind of need to almost bootstrap. They need to become almost startups. So this Senat is now sort of broken away. It's no longer part of the Centre for Low Carbon Futures. It's now a project that is run and managed by Sheffield University. And that, I don't think that would have been possible without using something like Azure, is my honest feeling. So, as you can see, Planky has infiltrated pretty much everyone's slide decks today. These are the next steps. We'll get there. Just sign up, do all the things, do the 6 steps. It is really good, and some of the content, certainly on the Azure training kit, we've used it heavily, and I recommend everyone have a play with it, because there's stuff in there that you didn't really know that you could do with the platform, and if you've got particular problems, it's a good place to start. So that's kind of it from me. Thank you, and if you have any questions, either ask me now or I'm around for a bit and happy to answer them.